means both. This one means or, one or the other, but the A is like an and also.
Yeah.
Okay, now this little prime at the top, it's a little prime to do A intersect B prime. Now there's all these formulas, but basically means everything that's not F or S from the S.
Okay.
So A and B not. You go back to your original list and you just cross out the ones that are already there.
Yeah.
And then it's everything else. A, D, H, J, K, and T. And then the N, the last part, the N means to count them. So you just literally count 1, 2, 3, 4, 5, 6 for that. So it's all about creating that set and then counting them at the end.
Mhm.
Move on to 16. Is that okay?
Yeah.
Great.
Just...
All right, so this time they don't give you any sets. They just tell you kind of what's going on with the number of elements in a set. Okay, so it says the number of elements in A is 50. We don't know what A represents. The number of elements in B is 40. We don't know what that represents, but we know that all the elements in A or B is 80. So Venn diagram is a good place to start here. The or means all three positions add up to 80. Okay, and then A, let's just call A on the left. So A plus the overlap adds up to 50, and then B plus the overlap, or this right hand side plus the overlap, it adds up to 40. So you could make a guess, but there is a formula here. I don't remember. Did you say you had a formula sheet for this?
No, I don't get
You do
one.
not. Okay. So the how do I want to do this here? The number in A or B is equal to the number of A plus the number of B minus the number of A or B.
Yeah.
No,
I think I memorize that.
I've got this one reversed. No, and B. Okay, that one. All right. So we know that this is 80. The first one is 50 and 40. So this must be 10 because 50 plus 40 is 90. 90 minus 10 is 80. So that goes right in the middle there. I know that's the answer, but if you just wanted to confirm your answer, the 40 plus 50 gets you to, I'm sorry, the 40 plus 10 gets you to 50. The 10 plus the 30 gets you to the 40. 40 plus 10 plus 30 is 80.
Yeah.
That's
Okay.
confirmed that. So that's your answer there is 10.
Yeah. Perfect. Thank you.
Yeah. Now, it looks like we'll be doing a Venn diagram maybe in another question coming up, but now you've moved on to counting methods, permutations, combinations, stuff like that.
Mm-hmm.
All right. Your local diner offers a meal combination consisting of an appetizer, a soup, a main course, and a dessert. So these are like buckets. Your appetizer bucket, your soup bucket, your main course bucket, and your dessert bucket. There are 5 appetizers, 5 soups, 6 main courses, and 6 desserts. Your diet restricts you from choosing between a dessert and an appetizer. So it's one or the other, basically. It's either, either you do an app or dessert. So you could kind of change this up a little bit. You could say it's either I have app, soup, main, or I go soup, main, and dessert. Kind of those are your two options there. How many 3-course meals are possible? So you're always multiplying between these buckets. But in the way that they've reorganized this, it's option 1 or option 2, which means you add between them.
Okay.
So there's this many options if you have an app but not a dessert. And then there's the second row here is if you have the dessert but not the app. So I believe it's like 150 plus 36 times 5, 180. So maybe 330 for the total.
Perfect. That was easy enough.
Yeah. All right. So 18 here. How many different sequences can be formed that use all the letters of the given word? So let me just quickly verify that I think I know how to do this. 1, 2, 3, 4, 5, 6. Okay. And are there any repeated letters in here? There are not. Okay, so that is how it's done. All right. So the way you do this is you go to that first one here and you first count the number of letters. So in this case, there are 1, 2, 3, 4, 5, 6 letters. And then you count any repeats. So this one has no repeated letters. Okay, which is good. We'll see that in the next two. So the number of sequences is the original count factorial over any repeats, which if there's no repeats, we'll just leave it as 1 for the moment. And then we'll talk about what to do when there are repeats. So 6 factorial, your calculator has a factorial button. Do you need help finding that, or do you?
Yeah, I don't know what that is.
All right. Let's see here. So I don't know where it is either. So let me believe it's under. Okay, so you want to go to math, PRB, and then it's number 4. So you'd first type in a 6, then you would go to math, PRB, and 4, and it will put this exclamation point there for you.
Perfect.
And that should equal 600 and 720.
Yeah. Okay.
All right, let me grab the next one here. The process is really similar. Count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 factorial in the top. Now you go letter by letter. So E occurs 1, 2 times. And then do any other letters appear more than once? So only one L, only one P. Okay, so any repeats get a factorial on the bottom based on how many times they repeat. So because there were 2 E's, it's 2 factorials.
Okay.
If there were 2 T's, there would be another factorial for the 2 for the T's.
Okay.
So just to be clear, this is for the E, this is for the total letters on this. So this is a shortcut. There is a justification for this, which you don't need at this point, but
Yeah.
just make sure that you can get that result there before we move on to the next one.
Yes. Yeah, I got it.
They often use like Mississippi. They'll use a word that has multiple repeats on the exam, like you see here with excellence. Excellence. So let's see here. 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 letters up top. E is repeated 1, 2, 3, 4 times. X is not repeated. C is repeated twice. And then L is repeated twice, or appears twice. So this means you're going to have a 4 factorial for E times a 2 factorial for C times a 2 factorial for L. So in terms of how you enter this in your calculator, you probably want parentheses in the bottom.
Okay. Okay, got that.
All right, so that takes care of 18, 19, another one of these problems here. All right, a 6-digit password to be formed from the digits 0 through 9, so that's 10 digits. How many different passwords are possible if the digits are repeated? So again, kind of that bucket problem. Each position represents a digit, 6 of them total. 1, 2, 3, 4, 5, 6. You can put a 10 in each position, because repeats are allowed. Like it's okay to have 6 zeros or 6 nines.
Mhm.
So this ends up being 10 to the 6th, which is one way it might appear, or a 1 followed by 6 zeros. It's just another way the answer might appear on the test. If there are no repeated digits. So the problem with the difference here is that while you still have 6 positions, get those labeled here, you cannot have the same digit. So you are essentially using one up. You're consuming one each time. So while you first have 10, like let's just say your first digit is 8. Well, 8's no longer allowed. There's only 9 that are now allowed, because you can literally not repeat. Now, real passwords they have different rules than this, but this is just a very simplistic thing. So it goes down each time. This is a permutation, but I think it's better to treat it as a bucket problem where you just figure out how many could go in each position and then multiply.
Yeah.
And it's substantially less, 151,200 passwords.
If it was a permutation, would it be like 10?
10p5.
Okay.
So how do you know that? This is the like total. I'm sorry, that's not right. 6 positions. This is the number of positions.
Okay.
And so that is in your calculator under math PRB, I believe. You should see an NPR. You do have to enter that 10 first, and then it'll say NPR, and then I think a 6. I'm just going to verify that real quick. Math PRB
What?
6. Yeah, let me snip that in. Okay, any questions before we move on to 20?
No.
Actually, let's do 21 first, because it's another permutation. It'll make more sense doing it this way.
Mhm.
All right, a professor wants to award prizes for first, second, third, fourth, and fifth in the class of 30. Again, it's kind of a bucket problem. You can do it as a permutation, but it's like how many people can finish first? And your answer might be, well, only one can finish first, but it's how many are available to finish first, 30.
Yeah.
But then someone is first, and that means there's only 29 for second, 28 for third, and so on for fifth. Now you can do a permutation. It's 30, 30p, and it's the number of positions, 5 in this case. Either way will work. Any questions on that?
Okay. No. Sorry.
All right, in number 20 here. Okay, in a lottery, you must select 6 out of 50 numbers. This is the first problem where they're not telling you anything about order. So permutations, order matters. So if it's a list, if it's a ranking, order matters. For combinations, order does not matter. I mean, think of like teams. If you and I are on the same team, it doesn't matter whether you were picked first or I was picked first. We're still on the same team. That's kind of the distinction here. So in this problem, it is a combination. It's NCR. NCR. So N is, again, it's like the total you're choosing from, and how many are you choosing? So you're choosing from 50, and you're choosing 6.
Mhm.
And that's, again, under math, PRB. You do have to put that number first. Clear that out. 50. What did I say? 6. There is a formula for this, but it's better to just use your calculator.
Yeah.
This one's quite large. All right, so that takes care of 7.3, 7.4. Is that okay?
Yeah.
All right, so let's look at 22, moving into probability. All right, consider an experiment where a fair coin is flipped 3 times, and let A represent the event that heads comes up at most 2 in the 3 flips. Okay, so we'll get to that in a moment. First, you've got to determine the sample space for flipping a coin. Okay, so
Mhm.
you know that it's heads or tails, right? But you want to do this orderly. So you write, okay, it could be heads, heads, heads. And then if you haven't done this before, you switch one at a time. So you might switch that last one to
Mhm.
that. Then you could go heads, tails, heads, heads, tails, tails. So notice, like, I switched the last one, and then I kept that one, kept that one. This is only half the
Yeah.
list. There's a number of ways to do this, but you want to make sure you get them all. So then it could be tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. This is not a math skill, but you do need this list to be able to do these problems.
Yeah.
All right, so at most 2 means it could be 0 heads, 1 head, or 2 head. So we're just counting how many
Okay.
0 heads are there,
Mhm.
and it's just the one there. How many places do you see just 1 head? So in the whole list, you're just 1 head. So 1, 2, 3, and then 2 heads. Let's see, there's 1, there's 2, there's 3. So there's 7 ways to get at most 2. So the probability of at most 2, it's 7 out of the total possible outcomes. So how many possible outcomes are there? There are 8, because we just listed them in this list here.
Okay.
There is another way to do this where you just look at the complementary answer, but this
Yeah.
is a small enough sample that it's okay to do it this way.
Okay.
Twenty-three here. Consider the experiment where 2 fair die, distinguishable dice, are rolled. So we consider 2 dice to have 6 sides, numbered 1 through 6. Let B represent the event that the sum of the 2 numbers is 5. So if you were to, and I'm not going to do this, but if you were to list them all out, this goes all the way up to 6, 6. Okay.
Mhm.
Now, some instructors actually throw in the table of what this is, but you want the sum to be 5. So it's
Yes.
like, how do you get to 5? Well, like 0 and 5 works, but 0 is not a possibility. Okay.
Yeah.
So it's got to be within the confines of this sample space. Is this clear? I mean, it's okay if you've never rolled a
Yeah.
dice before. I mean, I'm just
Yeah.
saying, we don't always do that. But what are the possibilities? It's it could be a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So there's kind of
Yeah.
this natural like ordering where this one goes up, the other one goes down. You want to have some organization when you're doing this, because if the number is larger, like let's say it's, I don't know, 7, there's more possibilities. You don't want to miss one in this case.
Yeah.
So there's 4 out of, well, how many possibilities are there when you roll 2 dice? So there's 6 numbers times 6 numbers. That's your total possibles on
Mhm.
that. So this is 4 out of 36.
Yes. Right.
And that does reduce. So you may, consider doing that. I don't know how the exam will be structured, but
Yep.
so this
I'll
would
be
be,
able to figure that.
so here's your, here's your list if you ever need that for another problem.
Yes. Thank you.
All right, so moving on here, 24 here. Okay. All right, so we kind of used this for we kind of did one like this earlier. Remember, we had like the number of A, the number of B, A or B.
Yeah.
This is it's very much related. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So this is just putting the numbers in if you know the formula. Okay, if you don't know the
Yeah.
formula, you're kind of stuck doing the Venn diagram thing, which would work. Just want to make sure you get all the numbers to sync up here. This is 0.6, 0.3. We don't know the middle one. The last one is 0.2. So it looks like B is 0.5 when you solve that. Let me know if there's any questions on how to solve this. I didn't really cover that, but
I think I got that down.
all right. $25. According to the Weather Service, there's a 75% chance of rain in New York and a 30% chance of rain in Honolulu. There's also a 10% chance that will rain in both cities. Complete the Venn diagram and filling in all 4 regions with the appropriate percentage values. Make sure that all 4 regions add up to 100%. So the regions they're talking about is 1, 2, 3, and 4. So there's this one that's outside the 2 circles that you might also need to fill in.
Okay.
So let's do that here. It doesn't let me do that. It's interesting. Okay, so you have to decide which one's going to be New York, which one's going to be Honolulu. Doesn't really matter. You start with the both though. The both is the best, the both or the and. That's the one that goes right in the middle. That's the one you start with. Now 75% New York is the full circle adding up to 0.75.
Mhm.
That's why it's 0.65 there. And then let me actually circle that. And then for the other one, for Honolulu, it's this whole green circle has to add up to 30%. So that's why it's 0.2 there. Now all four regions have to add up to 100%. So we've got 0.65 plus 0.1 plus 0.2. This equals 0.95. And there doesn't have to be a number in here. Like if these add up to 100%, then it's 0. But in this
Yeah.
case, there is 0.05 there. Now I'm using decimals. You can use percentages. Just depends how the problem is worded, how the answer is worded. Now that you have the Venn diagram, you can answer some of the questions. So you have to have the Venn diagram to answer this here. So what is the probability that it will rain in neither of the two cities? So in terms of the Venn diagram, that's like shading everything outside the two circles. That's
Yeah.
neither. So in this case, it's just 0.05. If you take a class on, more on probability, more on logic, you get really in depth in these.
Yeah.
Some really weird, things that they ask.
Mhm.
So exactly one of the two cities. So let me show you that here in the Venn diagram. That means there's no overlap. So it's like the half moon or the crescent moon on the left, crescent moon on the right. It's just those two values. So in your problem here, that would be the 0.65 plus the 0.2. Like that.
Perfect.
So it looks like 26 is yet another Venn diagram here. Do your exams typically have like a prompt that gives multiple parts?
Yeah.
Okay. Let me grab a nice Venn diagram here. Okay, so I was just reading here to myself. Okay, a survey found that 67% of high school graduating class went on to college, while 44% of the class was working. So this is going to be college. This one will be working. And then it says that 92% were either in college or working or both. So the sum of the two adds up to 0.92. And then this is 0.67, the circle on the left, this one on the right is 0.44, but none of that adds up. Like 0.44 plus 67 doesn't equal that. You have to go
Yeah.
back to the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B the other way. All right, so they give you that the OR is 0.92. This is 0.67. This is 0.44. So just quick calculation there on that. 0.67 plus 0.44 minus 0.92 is 0.19. So the one in the middle is 0.19.
Okay.
So then the college is 0.67. You have to combine that with the 0.19. So that's 0.48 plus 0.19 gets back to 0.67. Then on the right here, it's 0.44 is the whole one. 0.44, so that 0.19 plus some number, in this case 0.25, gets you to 0.44.
Yeah.
And then you might as well add them all up and subtract from one to get the missing one there. So it ends up being 0.08. Now you could like look ahead and only do the ones that you think you will need, but once you get the entire one filled out, it's very easy to answer each of the questions.
Yeah.
Any questions on how we filled this out or anything you want me to clarify?
No.
What percentage went on to college and work at the same time? So that's the intersection. That's that word and, that's key there. Question B here, what percentage, it's a bad snip, went on to college but not work? So they're in college, they're just not working. So it can't be any overlap with the working. So just the 0.48. Last one there, or neither in college nor working. Neither is always that one on the outside there. You can think of the neither. This number is always the neither. All right, so on to 8.4, more probability. Bag contains 5 red, 6 green, and 4 blue marbles. Okay, so I like to kind of indicate it, 5 red, 6 green, 4 blue. There's a total of 15 that we know, and it says 4 are drawn. 4 are drawn at random. Okay, so we need to do these one at a time. All right, so part A is all green. All right, so is this even possible? Can you? Yes, so there's 6 green. So you could actually grab all green. So here's how that works. There's 6 green to start with out of 15. That's the first selection that you make. Then you assume success. You know, this isn't one of those like what ifs. It's like you like assume it works. So if you
Yeah.
pull a green one out, how many green are left over? Well, there's one left green in there. There's 5 now, and there's also one less marble.
Yeah.
So then you do the same thing. You're like, okay, what if I'm successful again? 4 out of 13, because there's 4 greens that are left, 3 out of 12. So this is a good situation because there's 6, then 5, then 4, then 3. This goes down each time, and you get some number for that. Just looking at your answer sheet here, what does it do here? So it does do this as a fraction. Are you comfortable? So in your calculator, it's
Yeah.
top in parentheses, bottom in parentheses. Math, enter will get you back to a fraction.
Yes.
You need that. Okay, that's only part A, so there's plenty more to do here. Okay, part B. What's the probability that they're all the same color? So this is the probability of all green plus the probability of all red and plus the probability of all blue. Okay, so we already have the all green from the previous one.
Yeah.
So we got to do the all red. So it's very similar with the red. There's 5 reds. So that's 5 out of 15, 4 out of 14, 3 out of 13, and 2 out of 12. The all blue, there are 4 blues. So that's 4 out of 15, 4 out of 14. I'm sorry, 3 out of 14. These are times 2 out of 13 and 1 out of 12. Now keep in mind, these are all done sort of separately. It's like you do all the greens, then you restart, do all the reds, and then do all the blues and restart.
Yeah.
Okay. And that equals, you can look at the answer sheet. Is the setup okay though? Is
Yeah.
okay. Because these just get harder and harder here as we go. So if these aren't clear, then redo it here. So okay, at least 3 are red. So you're pulling 4 out. So you could have 3 red and 1 other, which you don't care about, or you could have 4 red and 0 others.
Yeah.
So it's good to break these apart into like, what is the possibility? So this is where it gets a little bit harder. The 3 red means that you're I don't want to say this. You are choosing 3 red, but you don't care about the order. So now this sort of bucketing doesn't work anymore because you don't know whether
Yeah.
it's these reds and then the other or the other. So you're essentially grabbing from the bucket, there's 15 and you're choosing 3 red.
Mhm.
I'm sorry, that's not right. Sorry. There were 5 red. You're 5 choosing 3 red. Times
Okay.
there are 10 non-reds and you're choosing one of them. Over 15 choosing 4. So a couple of things to notice here. Do you see how the 5 and the 10 add up to the 15, the 3 and the 1 add up to the 4?
Yeah.
So this one on the left here is the 3 reds, and this is the 1 other, and the combinations take into account the order, so you don't have to worry about that.
Yeah.
Plus, now we're going to do the other scenario, 4 red. So that's 5 choose 4 times 10 choose 0. So if you want to follow the pattern here, it's the first digits in front of the C have to add up to the one down here.
Yeah.
The second you have to add add up to the same thing. Now 10 choose 0 is 1. It doesn't contribute, but it's good to maybe write it if you want to show your work. So there's
Mhm.
and so this is a fair amount of work to put in the calculator, but this is it. I mean, this is the possibilities.
Yeah. Okay.
Part D, 2 blue and 1 of each of the other colors. All right, so we first want to do blue. So blue is how many blues are there? There's, let's see, there's 4 blues and you're choosing 2 of them. Times, so that's the blue. Let's choose a red. So the red is 5 reds and we're choosing 1 of them. Times, the last color is green. There's 6 green and we're choosing 1 of them. So 4 plus 5 plus 6, that's 15. And you're choosing 4 total on the bottom. And that takes into account everything. So how might you do this in calculator? I guess I didn't really talk about that. You would probably want to do these individually, like 4 choose
Yeah.
2, that, and then multiply them all out.
Okay.
All right, E, it's like, I can't believe we got to do, yet another one of these. But E is actually based on A. So A was probability of all green. Not all green is 1 minus the probability of all green. So you just take your result from A and subtract it from 1. So the word not always means 1 minus.
Yes. Okay.
All right, 28 here. These last ones sure do take a while. All right, Susan sees a bag of marbles. She grabs a handful at random. She has seen a bag containing 4 red, 3 green, 2 white, and 1 purple. She grabs 5 of them. Find the probability of the following events, expressing it as a fraction in lowest terms. So there are 4, 3, 2, 1. There's 10 total. That's important. And she's choosing 5. So on our bottom is going to be 10 C5 everywhere. if that wasn't made clear.
Yep.
Part A is she has all the red ones. Now encoded in that is a little bit of deception because there's 4 red, but she's choosing 5. Okay, so she's going to choose all 4 of the reds, 4 reds, and she's choosing all 4 of them. But that means she still's got to choose one more. There are 6 that she's choosing from. She still has to choose one of the other ones.
And then the ones on the top are multiplied by each other.
Yes, exactly. Exactly. All right, part B here. She has at least one white. We want to do this using complementary or not probability. So at least one probability that X is greater than 1, or at least 1 is equal to 1 minus the probability that X equals 0. Basically, this is 1 minus the probability of no whites.
Mhm.
And that's probably easier than trying to figure out like 1 white and then 2 whites and 3 whites and so on.
Yeah.
So probability of no whites, 10 choose 5 on the bottom. Okay, how many non-whites are there? There's 8. There's 8 non-whites, and you're going to choose 5 of them. Now, if you want, you can multiply by 2 whites choosing 0 of them, but
Mhm.
this will be 1. And then you subtract this whole thing from 1. Is that okay?
Yeah.
All right, part C. 2 red and 1 of each of the other colors. Okay. So let's first do the 2 red. The 2 red, there's 4 red and you're choosing 2 of them. And then we'll go to the next color. We'll go to green. So 1 green, 3 choose 1. And then white, 2 choose 1. And then purple, 1 choosing 1 of them. And again, it's 10 choose 5 for the rest on the bottom.
Okay.
Part D is very similar to the last part of the previous problem. It's asking for the probability that she does not have all red. Snip that in here. This reads to me, and this way you want to see it as 1 minus the probability of all red. Notice we did that in part A. So 1 minus whatever you had in part A as your answer.
Perfect.
All right, now we got a couple minutes left here. Anything else I could clarify? Quick questions to answer.
I don't think so. I think that covered everything.
How do you feel going into the exam?
I'm feeling pretty good. No.
Great. Do you have some time to review between, would you say it was tomorrow?
Yeah, it's tomorrow.
Okay,
Yeah, I'll have time to review.
great. Yeah, I believe I still have some times tomorrow if that's needed or not, no big deal. But yeah, good luck. I think you'll do
Thank
great.
you.
Just spend a little more time if you can. But